Okay, here we go. Welcome to
FawnMath number 2b.
Zoom out a little. Okay, so on this one, this is a pattern one, and we're supposed to count the number of toothpicks in step N. So these are all toothpicks.
Yep.
And then we build these patterns, and then this pattern would continue. And we're supposed to figure out at step N how many toothpicks are there going to be. What do you think about this problem?
Well, you could try to see the number of the toothpicks. Well, this is step 1 has 3 toothpicks.
Okay, good job. 3 in step 1.
And step 2 has three of those triangles, so that's gonna be 9.
Good job. Step 2 has 9.
What about but in step 3 you don't have 3 of these because you have this, that, and those, but you're counting those twice.
Yeah.
Well, you have 6 of these, so that you have 6 of step 1, so that's gonna be 8. That's gonna be 18.
Okay, good job.
Well,
all right, so good. That was good counting for these ones. What do you want to do next?
well, we could try to look for patterns in the numbers.
Okay.
Well, 3 times 3 is 9, and 9 times 2 is 18.
Yeah.
Well, I don't really see a pattern in the numbers.
Okay, well, why don't we make the 4th one then and see if we see anything else. So it's going to go like this. Sorry. I got off a little bit. There we go. Okay. How many toothpicks are going to be in this one?
Well, now you have some step 2s hiding in there.
Yeah, you do.
So there's that, and then there's that one on top, and then you have step 1 left over. So there's gonna be 30 toothpicks.
Ooh, good. That was an interesting way of counting them. You noticed there is a step 2, there is a step 2, there is a step 2, and then that one in the middle.
Yeah.
That was interesting. Do you see any other way of looking at how the pattern evolves?
Well,
Not just here, but all the way from the beginning.
well, you add on a layer. So if you had step N, then you'd add a layer of step N plus 1 triangles.
Okay, so what do you mean? So on step 1, what did we add? How many triangles?
We added 1 triangle.
Okay, on step 2, how many triangles did we add?
2. We
Okay.
added 2.
On
Then
step 3?
3.
On step 4?
4. So it looks like if you're on the N minus 1 step, you're going to add a layer of N.
Well, let's see. Remember, on the nth step,
In the nth step, you're going to have
how many did we add on when n was 1? How many did we add?
1.
When
So
n was 2, how many did we add?
2.
When n was 3, how many did we add?
We add 3.
So on the nth step, how many triangles are you going to add?
You're going to add N.
N. Add n triangles. So that's an interesting.
So now you can figure out any N.
Yeah, yeah. So how can we use this idea to figure out how many triangles there are on any n?
Well, on each triangle, there's 3 toothpicks.
Right? So once we figure out the number of triangles, then we just have to multiply by 3 to get the number of toothpicks.
Yeah.
So now we just have to figure out the number of triangles.
The number of triangles. Well, there's 1, 3, 6, 10.
1, 3, 6, 10.
Well, this is what you're adding on this. You're adding on 2 here, plus 3 here, and plus 4 there. So it looks like if you're on the nth step, you're gonna add n plus 1. You're gonna add n plus 1 triangles.
Because why?
Because this is one triangle,
Yeah.
and then plus 2, you're gonna add, then plus 2 is 3,
Uh-huh.
and 1 is 1 less than 2.
Okay, so to go from this step to the next step, you add whatever this step is
Plus
1 triangles. So this is the fourth step.
So
So
plus
we would
5.
plus 5, and where would we end up?
15.
Okay.
Then plus 6. 21.
Okay.
Plus 7.
Good job. So that now you're understanding how you walk down here.
Yeah.
But can we figure out a formula for it?
Well, on the nth step, to get to the next step, you add n plus 1.
Right.
To get to the next step, and then you keep doing that over and over.
Okay, so how do I get to number 10 here? If I start at the beginning, how do I get to the number 10? What happens?
Well, you add 2.
Where do I start? What
You
number
start
do I
at 1.
1.
Then plus 2, then plus 3, and then plus 4, and then
And what is this equal?
the whole thing equals 11 now, because 2 plus 3 is the whole thing equals 10.
Ah, awesome. So what do you think I'm going to have to do to get to the nth step here?
You're gonna have to add the numbers up to n.
Aha.
Plus all the way up to n.
Okay. Do you know how to add this up? Do you know how to do that?
You use the backwards trick,
Use the
and then
backwards.
divide
thing.
by 2.
Aha. So let's do that. Okay. 1 plus 2 plus 3 plus 4 plus n. What's the backwards trick?
You do n plus n minus 1 plus n minus 2 plus n minus 3 all the way down to 1.
Okay.
And then you add this
Okay.
together, and then you divide by 2.
Okay, what do I get when I add?
N plus 1
N plus 1
plus n plus 1
n plus 1
plus n plus 1. You're gonna get a bunch of n plus 1s.
How many n plus 1s do I get?
n plus 1
N times n plus 1.
divided by 2.
Okay, why do I have to divide by 2?
Because when you use the backwards trick, you're adding on this lower step, and then you have to divide by 2 to get rid of it.
Okay, so I added on the same thing. This list of numbers is the same as this list of numbers, right? So I have 2 of them.
And then
Now I divide by 2. So that's how many triangles I have on the nth step.
Yep.
How many toothpicks do I have after the nth step?
Well, there's 3, 9, 18, 30.
How did I go from the number of triangles to the number of toothpicks?
You multiply by 3. Because each triangle contains 3.
Very good. Very good. This is a tricky pattern problem,
Yeah.
isn't it? You happy you figured that one out?
Yeah.
All right, good job. Good job.